Okay, so today I'm going to do a little experiment, just make some solutions. As I make them, you're going to want to monitor what I do so that you can answer the questions that are going to be on the quiz related to this video. All of these answers and all the things I do should be review for you, but they'll also help remind you and prepare you for the lab final, right? The lab practical. Okay, so first off, I have a 100 milliliter volumetric flask. I'm going to weigh out some weight load here. If you can come and get this guy here. So I have some sodium hydroxide. Oops, there we go. Sodium hydroxide. And I'm weighing out 0.4 grams. Or well, I'm going to try to weigh out around 0.4 grams. Let's see how many I weigh out here. One more. Alright, so I have 0.395 grams of sodium hydroxide. Alright, there's my sodium hydroxide. Again, I'm going to put the sodium hydroxide into this 100 milliliter volumetric flask. Okay. Alright. Got it. This is my sodium hydroxide. Alright. Now I'm going to make some HCl or some H2SO4. Do as you order, add acid to water, right? So I'm going to put a little bit of water in here before I add the acid to it. Okay. This is a 2-liter flask, 2-liter volumetric flask, and I need a micropipe. So I'm going to put it to 550, 1, 2, 3, 4, 5. 555 microliters. Okay? 555 microliters. I have my sulfuric acid here. I'm going to go in the hood so when I open this, it doesn't smell bad for us. So, one aliquot of 555 microliters. Get a second aliquot of 555 microliters. You can see that this is concentrated sulfuric acid. The molarity of concentrated sulfuric acid is 18 molar. 18 molar. So, grab the lid here. Again, this is 2 liters. bit more. There we go. Okay. So now I have my acid. So I made up a base, my sodium hydroxide. Again, it's 0.4 grams of sodium hydroxide in that 100 milliliters. This is 2 aliquots of 0.555 or 1.110. Is that right? 1 milliliters. 1.110 milliliters. Okay. Concentrated sulfuric acid. Again, the sulfuric acid, the concentrated sulfuric acid, we put there, and we just added here. Its concentration is 18 moles per liter, right? So now we have our base, we have our acid. Alright, so those are the two solutions that I made. I have some phenolphthalein here. Put a drop of the phenolphthalein into my, whoops, a lot of drops. Have some phenolphthalein in here, right? I can add a little bit of water to it. Alright, now, we worked with phenolphthalein before. We know we worked with the carbonate lab, right? We started off with sodium carbonate, and we gradually added HCl. And the solution changed from, if you remember, it changed from pink to white. So what will happen when I add sodium hydroxide, or sulfuric acid, H2SO4, sodium hydroxide, and I have a couple of, I have this beaker here which has my phenolphthalein and some water, right? Well, let's say that I add up to 10 milliliters there. So if I add 10 milliliters of my sodium hydroxide solution into here, first of all, we'll expect it to turn color, right? Because the phenolphthalein is pink above pH about 8. Alright. If I have a similar beaker here, and I put in a few drops of phenolphthalein, and I add my acid. Then the solution doesn't change colors. Now, I have a solution of base here. Volume's about 30 milliliters, but I added exactly 10 milliliters of the base to the water and the phenolphthalein. So the question is, how much of this do I have to add to get it to turn colors, back to colorless? Alright, so it changes colorless. How many milliliters of this acid solution does it take to change 10 milliliters of this base solution colorless? Alright, so that's the question you're going to want to answer. That's the last question, or one of the questions on the quiz, along with a few other questions based on the calculations we've done. And if you can follow the steps and identify the concentrations and answer that question, then that will help you prepare for your lab final.